Hello and welcome to ISM 240, Unit 2, specifically chapters 4, 5, 6, and 7. What I did was I took a look at the individual items that were introduced in all the chapters, and I tried to pull out some basic fundamental things, and I'll try to elaborate on those to give you a little bit better idea of what's going on and hopefully facilitate those things moving along. I thought chapter 5 is fairly upfront, so I didn't really go into those. The very first thing I want to talk about is parameters in reference to call by value and call by reference. So call by value and call by reference are utilized in reference to functions. And if you think back to when we were talking about functions when we use our calculator, I put in two numbers, I push equal sign, it goes away and does something and then comes back. Functions can be user created. Some of them actually come with your program itself, or whatever programming language you're using. And as you well know, on your calculator, if you have a function-based calculator, you put your function key and then it does whatever the calculation is. But the way it works is a function is set to receive a few values. It could be the function could be called function add numbers, and it takes in two values. Sorry about that. It takes in two values, int num1, int num2, and it's going to return an integer. Now I'm using some Visual Basic syntax, kind of pseudo syntax. I'd have to get the exact syntax, but what's going on is basically whatever this does. I mean, you can look at it based off what I've called it. Oh, it's going to add two numbers. It's going to take in this number, it's going to take in this number, and it's going to return this number. When call by value and call by reference are concerned, they're talking about these values right here. When we're adding two numbers together and we have an expectation that we're going to return the value itself, we are sending a copy of those variable values to that function to be used in that function. And I know that sounds kind of weird, but if we go back to our last week when we were talking a little bit, or where you learned, if I take a look and I say, all right, this is my variable, right? And it's going to be called int number 1, okay? And in that variable called int number 1, it's a container, and I'm going to put in a number 2, right? So if I'm going to call a function and I'm going to send it int number 1 and I'm going to send it a value, what it does is it actually sends a copy of this variable value to the function to then have whatever performed on it. So here's my copy, let's say. I go away to my function. It does whatever it is. It can take int number 1, add int number 2 together, add another 10, multiply by 20, whatever, and then return the value. But since this is a by value call, or a by val call, right? It sends the copy and never touches this. It'll never change from a 2 because it sends a copy to the function. So if we assume that this is the function right here, it's sending a copy to the function. So we're going to say it sends a copy, and then the function or procedure then does whatever it wants to it, and it returns what it calls the return, but it does not modify this in the instance of a by value call. That's what that is. Now, if we take this and we turn it into, it's so tiny. Can I make it bigger? You can tell how often I use this. Okay, well, we're going to do a bigger brush here. There. Oh, no. There we go. So we're getting rid of this. All right, so we've done a by value call, right? We've sent what we needed there. Now what we're going to do is we're going to change it to a by reference call. Now the difference between a by reference and a by value, they're syntaxed in the actual code itself, but we're just going to make this a by reference call. Now when we make this a by reference call, what that does is that sends it sends the actual original to the function or procedure. So now rather than sending a copy of the data, what I'm doing is I'm sending this entire variable to the function or procedure. So now what happens is inside the function or procedure, it has the ability to modify and change that value. So now I can go from a 2 to a 4 to whatever, and then outside of that function or procedure in the main program, it is now changed. So if down here, I have changed this to a 4, when I'm done with my function or procedure call, that 4 will be the value because it hasn't sent a copy. Whereas before, if this was a 4, this would have still been our 2 because it would have maintained the value and simply sent a copy to our function or procedure. So once again, a by val call sends a copy to the function or procedure, and a by reference call sends the location of the actual variable. So anything that happens to the variable in the function or procedure happens outside of the function or procedure itself. So that's that. Alrighty. Now let's continue. And then we also talked about return values, which is good. Return values are what it actually returns when we add our two numbers. A return value would be, the first number plus the second number. A return value would be the answer. Local and global variables. Now this concept is interesting because you're not really dealing with the syntax of the programming language itself, but you're dealing with a concept. All right, so this is our overall program. Inside that program, we might have functions, procedures, things that it's doing. In Visual Basic, there's event-driven functions. If we declare a variable here, this is a global variable. If we declare a variable there, that means everything knows what it is. Everything. Well, poop. Let me just undo that real quick. All right. So not only does the overall program, but every function, every event-driven item within it knows exactly what it is. Whereas if I create a local variable, only this function, procedure, event-driven item, whatever, can understand what that variable is unless you pass it back and forth. Remember when we were dealing with parameters, call by value, call by reference? If you have a variable that's global, you don't have to pass it to those because it already knows what it is in that function or procedure because it doesn't need to be a parameter. You want to try to generally avoid global variables, but the most simplistic way is global variables, everything knows what it is. That's the variable scope. Local variable, only the function or procedure knows what that is. I may be oversimplifying it, and when we have our collaborate session, it'll be there, but I just wanted to give you a little bit more of a heads up there. All right, now we're moving on to our if then else. I took a look at the PowerPoint and I thought, wow, this is really making this overly complex. At the basis of what an if then else is, you're making a decision. That's it. It's a black and white decision, one way or the other. That's an if-then. If it's rainy outside, grab your raincoat. Else, don't grab your raincoat. That's it. I really don't know a better way to go about talking about it, because if we take a look here, here's our kind of our breakdown from our PowerPoint. Oh, very pixelated. Okay, but look. So here's our if statement. This is our decision statement. If it's rainy outside, wear the raincoat. If it's not rainy, don't wear the raincoat. There you go. And if you have an else statement, here's your true statement, and then your else is your what it does if it's not true. It's do this or this. That's what the basis of the if-then. The raincoat is a good example. You can look at your gas gauge. If their warning light is on, get more gas. Else, don't get gas. I hope that helps a little bit. And I might be, like I said, I might be oversimplifying it, but there's a lot more nuances to it and things along those lines, but that's the basis of it. It's a black and white logic problem, one or the other. So that takes a look at that. Now what I want to do is I want to talk about the do while and the repeat until. They work the same way, they just test in different circumstances. Right. The do while loops while this is true. You know, if you're entering input into a number box online, you know, you're entering in numbers 20, 30, 40, 50, 60, and then enter in a negative number to stop. I think we've all seen those. That's a do while conditions. So as long as the number is not negative, it can continue to loop and ask you questions. As soon as the number is negative, it stops. That's a while condition. A repeat until might be you have an accumulator in there. An accumulator might look something like I equals I plus 1, meaning every time it runs through, the variable I goes from 1 to 2 to 3 to 4 to 5 to 6 to 7. And you might loop until I equals, so it might look something like this. Repeat until I is greater than or equal to 10. So this is where it adds I, and then we print I. Now this is my syntax my syntax is not right here, but it's very simplistic. All we're doing is we're saying, okay, I'm going to add one I. Each time I go through, I becomes 1. I starts at 1, 2, 3, 4. Every time we add 1 to it, I is 1. I print 1 to the screen. I is 2. I print I 2 to the screen. I 3. This should be 10, by the way. And I continue to print until such time as I is greater than or equal to 10. So as soon as I is 10, it stops. It's done, right? And if I was going to change this with my while condition, while I is less than 10, I equals I plus 1. Oh, poop. Print I. And all I'm doing in this case, adding one to I, continuing to add 1, printing it out to the screen, and as long as I is less than 10, it does it. All right, that concludes a little bit of a basic introduction to some of the subjects at hand. We will probably have our Collaborate session towards the end of the week. We'll be able to talk a little bit more, but I hope that gives you just a general idea of what you need to look for and a general idea of what you're working on. Thank you for your time.